Hello everyone, my name is Kishan. I'm studying in Sri Venkateshwara College of Engineering, third sem. Subject is mathematics and the topic is the ANOVA technique. The ANOVA technique. Introduction to ANOVA. ANOVA stands for Analysis of Variance, a statistical method used to compare three or more group means. It helps determine if at least one group means is significantly different from the other, which technique is widely used in various fields including psychological, medicine, and agriculture. Purpose of ANOVA. The primary purpose of ANOVA is to test hypotheses about group means. It assesses whether the variability between group means is greater than the variability within groups. This allows researchers to identify significant difference with increasing the risk of type 1 error. Types of ANOVA. There are several types of ANOVA including one-way, two-way and repeated measures ANOVA. One-way ANOVA examines the influence of one dependent variable on a dependent variable. Two-way ANOVA evaluates the interaction between two independent variables on a dependent variable. One-way ANOVA basics. One-way ANOVA is used when comparing three or more independent groups. The null hypothesis states that all group means are equal. If the null hypothesis is rejected, at least one group means different significant. Two-way ANOVA basics. Two-way ANOVA analyzes the effect of two independent variables simultaneously. This method can also access interaction effects between the two independent variables. It provides a more complex understanding of how variables influence the dependent variable. Assumption of ANOVA. ANOVA relies on several assumptions for valid results, including normality. The response variable should be normally distributed within each group. Homogeneity of variance is another critical assumption, meaning variance across groups should be equal. Conducting ANOVA. To conduct ANOVA, research first collects sample data from different groups. Next, they calculate the group means and the overall mean of the data. Finally, the F statistic is computed to evaluate the variance between groups relative to within groups. F ratio explained. The F ratio is the code of ANOVA and reflects the ratio of variance between groups to variance within groups. A higher F ratio indicates a greater likelihood that the least one group mean is different. Researchers compare the computer F ratio to a critical value from the F distribution to draw conclusions. Post-HOC tests. When ANOVA indicates significant differences, post-HOC tests identify which specific group differs. Common post-HOC tests include Turkey's HSD, Bonoforon, and Schwell's test. These tests control for type 1 error across multiple comparisons. ANOVA in research. ANOVA is often used in experimental research to evaluate treatment effect. It can help identify interactions between different factors affecting an outcome. This technique is crucial for designing experiments and interpreting results. ANOVA versus t-tests. ANOVA is more appropriate than t-tests when comparing three or more groups. Using multiple t-tests increases the risk of type 1 error, while ANOVA controls for this. ANOVA provides a comprehensive view of group differences in one analysis. Practical applications of ANOVA. ANOVA is applied in clinical trials to access treatment efficiency across multiple groups. It is used in agricultural research to compare yields and different fertilizer treatments. In marketing, ANOVA helps evaluate consumers' preferences across various product designs. Interpreting ANOVA results. The ANOVA output includes the F statistic, p-value, and degree of freedom. A p-value less than the significance level, commonly 0.05, indicates a significant difference. Results should be contextualized within the research framework and subject matter. Limitations of ANOVA. ANOVA assumes normal distribution, which may not always hold true in real-world data. It can also be sensitive for outliers, which can skew results. ANOVA does not indicate which specific group is different. Post-HOC tests are necessary for this. Software for ANOVA. Various statistical software packages can conduct ANOVA, including R, SPSS, and Python. These tools streamline the analysis and provide detailed output for interpretation. Users should be familiar with the software syntax and output formats for effective analysis. ANOVA in quality control. In quality control, ANOVA accesses variation in manufacturing processes. It helps determining if changes in production method affect product quality. This technique supports continuous improvement initiatives in various industries. ANOVA for factorial designs. Factorial designs allow researchers to study multiple factors simultaneously using ANOVA. This approach enhances efficiency and provides insight to interaction effects. It is particularly useful in agriculture and industrial experiments. Reporting ANOVA results. And reporting ANOVA results include the F statistics, degree of freedom, and p-value. Graphical representation such as bar plot enhance the presentation of results. Tree development may enhance the robustness and applicability of ANOVA in various fields. Thank you.